Okay, so we are now going to do questions 13 through 24 for the January 2015 Algebra 1 Regents. So 13 says Connor wants to attend the town carnival. The price of admission to the carnival is $4.50. And each ride costs an additional 79 cents. So reading this part, I'm already thinking, okay, so 450 is going to be our constant. Y-intercept. Well, it's 79 cents per ride. So 0.79 is going to be our slope. If he can spend at most $16 at the carnival, which inequality can be used to solve for R, the number of rides Connor can go on, and what is the maximum number of rides that he can go on? All right, so I already filled in some of this information. So we got 0.79 R, where R is the number of rides, right? So 0.79 cents per ride, plus our constant admission fee of $4.50. So that's going to be part of our inequality so far. That's the amount of money Connor spends. So that has to be less than or equal to 16, seeing that he can't spend more money than he has. So the two we can get rid of based on that is 1 and 2, because the 79 is incorrect. And now we just need to determine how many rides he can ride. Okay, so for this, what I would do is put this in your calculator. So you got 0.79 times, let's test 3 first, so times 14 plus 450. That gives us $15.56. So he can ride 14 rides. Let's see if he can ride 15 rides. So I'm going to press second, enter. That's the entry option. It's going to give you the last thing you typed in. I'm going to change that 14 to a 15. But unfortunately, that went over $16. So he can't ride 15 rides. He can ride 14. Question 14. Corinne is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. She constructed box plots shown in the diagram below. So for this, it's going to be important to know the parts of a box plot. So I'm going to color code this. So the first line is the minimum. The second line is the first quartile. The third line is the median, which is sometimes called quartile 2, or the second quartile. The fourth line is the third quartile, sometimes known as the upper quartile. And the last line is our max, right? So the median is just that median line I talked about. We know range, right? Range is something we're very familiar with. It's just the max minus the min for the range. I know that's a little hard to see, but that's not really as important. What's more important is the interquartile range. So the interquartile range is going to be similar to the range, but instead of the max minus the min, we're going to find the range of the quartiles, which is going to be the third quartile minus the first quartile. And that's going to give us the IQR, or the interquartile range. And then as you see in each option, these lines are just connected with our box in the middle and then our whiskers at the edge. So which one of these has the highest median, and the smallest interquartile range. Uh-oh. Okay. So let's look at our medians first. So I'm just going to kind of drop every line down. We might have to approximate it, but that's okay. So we got approximately what? 78, approximately 86, approximately 78, and approximately 85. Okay, so which destination has a median temperature above 80? So that gets rid of Ocean Beach, and it also gets rid of Serene Shores. Now, Whispering Palms and Pelican Beach both have a median temperature above 80, but the one with the smaller interquartile range is Pelican Beach, since our quartiles are closer together. So the answer is Pelican Beach. Okay, 15. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals 5,000 times 0.98 to the x power represents the value y of one account that was left inactive for a period of x years. What is the y-intercept of this equation, and what does it represent? So thinking about an axis, the y-intercept is where the graph crosses the y-axis. And that's going to happen, so all of these points, these random points that I'm graphing, let's say that's the point 0, 4. We got 0, 2. We got 0, -3. So all the x values are 0. So if we were to do 5,000 times 0.98 to the 0 power, anything to the 0 power is 1. So we're just going to get 5,000. So it's not 1 or 2. 3 says 5,000, and it's the amount of money in the account initially. 4 says 5,000, and it's the amount of money in the account after X years. Well, if X is 0 and X is years, it's the 0 year, which is in the beginning. So that's going to be initially. So it's going to be 3. Question 16. The equation for the volume of a cylinder is V equals pi r squared h, which is pi times r squared times h. The positive value of r in terms of h and v is. Okay, so they want the positive value of r. So we want to, this is what we're solving for. We're solving for r. So we got v equals pi r squared h. There's a little bit of a delay now. Hopefully I don't have to remake this. So we want to get r alone. So what's going to be helpful here is if we start by getting rid of the other things we're multiplying by. In this case, pi and h. Same thing, whatever you do to the left, you got to do to the right. Pi times h. My pi is looking a little weird. Don't really know why. So now we have v equals pi times h, which equals r squared. And to get rid of that square, you got to take the square root of both sides. So we're going to get r equals the square root of v divided by pi h. And that's option 1. 17. Which equation has the same solutions as x squared plus 6x minus 7? So the first way you could do this is by factoring. We're going to find the factors of negative 7 that add to positive 6. So what are our factors of negative 7? We got 1 times negative 7, and we got negative 1 times positive 7. And when we add those, 1 plus negative 7 is negative 6, and negative 1 plus positive 7 is positive 6. So we want this set, and we got x minus 1 x plus 7. Which I'm realizing is definitely a way to do this. However, I'm noticing that this one is a little bit more complicated than what I had just started. We don't like when things are more complicated, so we're going to make this easier on us. And we're just going to use our calculator. But we can't use our calculator with the way that they're shown right here. So we got to subtract whatever's on the right side of the equal sign from the left. So this is going to be minus 2, minus 2, minus 16, minus 16. Okay, so now we're looking for whichever ones have the same solutions, and those solutions, using what I did before, are going to be 1 and negative 7. All right, so let's go to our calculator and go into y equals. Okay, so y equals, and we're going to put, we can put both of them in, even though using the work I did before, I already found the roots, but it's still helpful to put it in. So x squared plus 6x minus 7. And let's do each answer choice now. So we got x plus 3 squared minus 2. Second graph. So we're looking for when y is 0. So we can see that y1 is 0 when x is 1. But y2 is not 0 there. So already they don't have the same solutions. So let's try a different one. Option 2 is x minus 3 now. So we get second graph, go to the table. So when we know that one of the zeros is when x is 1, but the second one is not 0 when x is 1. So that is also not our answer. Okay, so I'm going to test option 3 now. It's still x minus 3, but now on the outside we have minus 16. Second graph. So y2 does not have a 0 when x is 1. Go back to y equals, plus second graph. For this one, we can see that y is 0 for both equations when x is 1. Let's go and check negative 7. Same thing here, same zeros. Actually, the entire table is the same. So that's what we're looking for. Our answer is 4. All right, 18, two functions. We got y equals the absolute value of x minus 3. That's going to be an absolute value function. And 3x plus 3y equals 27, which is going to be linear, are graphed on the same set of axes. Which statement is true about the solution to the system of equations? Okay, so we do have a system of equations here. We have two equations. One's absolute value, one is linear. And when we find the solution, that's going to be where the graphs cross. This is going to be another one where our graphing calculator is helpful, but we cannot use it yet because this is not in y equals mx plus b form. So let's go ahead and fix that. So you want to solve for y here. So I like to put a line down that. And this is the term we want alone for now. So let's do minus 3x minus 3x. I don't know why I got tilted. I'm going to untilt it now. We got 3y equals, I'm going to put negative 3x first and keep 27 positive. Okay, now we need to get the y by itself. So to do that, we divide everything by 3. And we get y equals negative 3 divided by 3 is negative 1. X, 27 divided by 3 is positive 9. So now we're going to put both of these into y equals. So first we put the absolute value function. To get absolute value, you're going to have to go to math. You go right to num, and the ABS option 1 means absolute value. I think there is another way to get absolute value, but this is the way I use. And then you close your parentheses. The absolute value of x minus 3. And this one is going to be negative 1x, or just x, plus 9. So we can press graph to see what this will look like. So there's our absolute value, there's our linear. But to find that exact point, it looks like it's going to be about 6, 3, which is an answer choice. But let's get that more precise. So we're going to go down. Okay, and as we can see, when x is 6, both y values of both equations, both functions, are 3. So 6, 3 is the solution because it does satisfy both equations. So this answer choice is 3. Question 19. Miriam and Jessica are growing bacteria in a laboratory. Miriam uses the growth function, f of t equals n to the power of 2 times t, while Jessica uses the function g of t equals n to the power of 4 times t, where n represents the initial number of bacteria and t is the time in hours. If Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve the same growth over time? Okay, so let's see. So we have Miriam, which is f of t, starting with 16. So that's 16 2 to the t. And we can rewrite this as 16 squared to the power of t. So that's going to be the same thing. So you can, when you raise a power to another power, you just multiply these. So I rewrote it backwards because I can now do 16 squared which is 256. So we get 256 to the power of t. Right? But Jessica's is n to the 4t. So we want to know, how can we rewrite Jessica's so that we have n to the 4 to the t, and that n to the 4 equals 256 because we want the same growth. So basically, what to the 4th power is 256? So to do that, we're going to find the 4th root. So 4, it's kind of like square root, but the 4th root. So we can do that as well. So we're going to actually press the 4 button first. And then we're going to press, I think we have to go to math. So you see this 5, key 5, it's the x root. And then you put the number in. So 256. So here we get 4. Okay. 20. If a sequence is defined recursively by f of 0 equals 2, and then f of n plus 1 equals negative 2 f of n plus 3, when n is greater than 0, then f of 2 is equal to what? Okay, so these are like different steps where every input that is in the parentheses where n is the step. So when n equals 0, we get f of 0, and they define that for us, which is 2. So now let's find 1. So let's find when at the first step when n is 1. Well, that's going to be f of 1. We don't know what f of 1 is, so we need to use this function. So I'm going to rewrite this because we have f of n plus 1, right? So we are going to do, to find f of 1, that is going to be f of 0 plus 1, which is negative 2 times f of n. And in this case, our n is 0 plus 3. And based on the step before, we know that f of 0 is 2. So we get negative 2 times 2 plus 3. Negative 2 times 2 is negative 4. Plus 3 is negative 1. So we now know that we got f of 0 equals 2, and f of 1 equals negative 1. And we just need to find f of 2. So to find when n is 2, to find our next step, we need to do f of 1 plus 1. All right, I'm going to erase this because I'm worried that that's going to get confusing. Because now in this case, our n is 1 to find f of 2. So now that equals, we're going to use the function negative 2 times f of n. We said that n is 1 plus 3. We get negative 2. We know that f of 1 is negative 1 plus 3. Negative 2 times negative 1 is 2 plus 3 is 5. So our answer is 5 because we're looking for f of 2. Question 21. An astronaut drops a rock off the edge of a cliff on the moon. The distance, d of t in meters, that the rock travels after t seconds can be modeled by the function 0.8 t squared. This is the average speed in meters per second of a rock between 5 and 10 seconds after it was dropped. So we want to know the average speed. So we have to look at the distance between the two and find its average rate. So let's start. We know that we can use a table here. So if we use not x, t and d of t, and d of t. We know that when we're looking for when t is 5 and t is 10. So we need to know what is the distance. So I'm going to use the graphing calculator just to make life easy. So 0.8. You don't have a t, so I'm going to use x squared and second graph. So when x is 5, when t is 5, d of t is 20. And when t is 10, d of t is 80. So now we do 80 minus 20 over 10 minus 5. We get 60 over 5, which is 12. 22. When factored completely, the expression p to the fourth minus 81 is equivalent to. Okay, so we can use our graphing calculator here. However, there are going to be at least 2 of these that come up correctly. And the reason why 2 of them are correct, but there's only one right answer, is because it's saying factored completely. So I'm going to do this by hand. Looking at this expression, the first thing I notice is p to the fourth is a perfect square. And I know this because it has an even exponent and a perfect square coefficient. In this case, that perfect square is just an imaginary one. I also know that 81 is a perfect square. Right, because the square root of 81 is 9. So that's a perfect square. So this is the difference, because we're subtracting. So it's the difference of perfect squares. And when we have the difference of perfect squares, we rewrite it like this: the multiplication of 2 binomials. We take the square root of the first one, which is going to be the square root of the coefficient, which is just 1, and half the exponent. So we get p squared and p squared. We take the square root of the second term, which is 81, and the square root is 9. So we put 9 and 9. We're going to just alternate our signs. Right? So if you were to put this in the graphing calculator and you were to stop here and look at the table, you would say, oh, well, 1 is right, but it's not factored completely. Because something else I notice is that p squared is also a perfect square, because 1 is a perfect square and 2 is even. 9 is also a perfect square. So we actually have the difference of perfect squares here twice. P squared plus 9. And let's write this again. Square root of p squared is p. Square root of 9 is 3. And we get plus minus. This is factored completely, and your answer choice is 3. Question 23. In 2013, the United States Postal Service charged 0.46 cents to mail a letter weighing up to 1 ounce, and 20 cents per ounce for each additional ounce. Which function would determine the cost in dollars, so C of Z, of mailing a letter weighing Z ounces, where Z is an integer greater than 1? Okay, so we know that our constant rate, so no matter what your mailing. It doesn't matter how much it weighs. Your constant rate in 2013 is going to be that plus 0.46 cents. That's not changing. What is going to change is the price depending on how many ounces it is. So this is going to be 20 cents. So 0.20 cents per ounce, right? But it's per ounce of additional. So that first ounce does not count. We have to get rid of that first ounce. How do you get rid of a first ounce? Or how do you get rid of something? You subtract z minus 1. So it's 20 cents times z minus 1. So 1 ounce less than however much, because that's included, plus 46 cents for that first ounce. So we look through our options, and that's choice 4. Okay, last question, this multiple choice. A polynomial function contains the factors x, x minus 2, and x plus 5. Which graph below could represent the graph of this function? Okay, so you could write this out as x, x minus 2, and x minus 5. All right, that got crazy. And knowing that it's going to look like this, you can, because factors means we're multiplying, right? So you can multiply these all out. But we don't actually have to multiply them. We want to know about the graphs, right? And the easiest way to compare functions like this is by looking at the roots. So we can see that every graph has different roots. The first one has 3. The third one also has 3, the 3 different ones. The second one only has 2 roots. And remember, roots are where your graph crosses the x-axis, right? And when it crosses the x-axis, your function equals 0. So we actually have to find, for each one of these factors, when we have to set each one of them equal to 0. So the first one is x equals 0. And that gets rid of graph 2 because you can see right here the function does not cross at 0. Okay, let's continue. We got x plus 2 equals 0. Sorry, not x plus 2. X minus 2. We add 2 on both sides. We get x equals 2. So we're looking for it to cross at 2. This one, in option 3, it does not. So it can't be 3. Option 2 does. Same thing here. You add 5. Sorry, that was plus 5. So you subtract 5 on both sides. You get x equals negative 5. And that is also correct over here. So it's only going to be 1. And this was another question you could have done on your graphing calculator once you rewrote it like I did down here. So you go to y equals and you type that in. X times x minus 2 times x plus 5. Go to graph. Okay, it's a little zoomed out, but you can see so our answer choice is 1, but the graph doesn't match it. But I guess they do cover themselves because it said could represent. So 1 is the only one that could represent it because it does have the same roots, even if the graph looks a little different. All right. And that is the multiple choice of the January 2015 Regent, questions 13 through 24.